Hello everyone. As you know, we are dealing with the chemical properties of phenol, and the first chemical properties are in which phenol is showing acidic behavior. Means it is going to lose H positive ion. Before that, we have done all comparisons, acidic comparisons related to phenol. Now it's a time to understand those chemical reactions in which phenol is showing acidic behavior. Topic is for 12th, JEE, NEET and BSc. Let's check which reactions they are. Total three reactions are there. First with this compound, acetyl chloride. If IUPAC naming you will do ethane 1-onyl chloride. Second compound to which it will react, it is this acetic anhydride. Acetic anhydride. It's a common name. Its IUPAC naming is ethanoic anhydride. Here its common name is acetyl chloride. And IUPAC naming is ethane 1-onyl chloride. So you can note down their common names and IUPAC names. And third one will be this compound. This one, benzoyl chloride. This one. So these three compounds are going to react with phenol, and when phenol will react with these three compounds, phenol will show acidic behavior. Up to 12th level, first I will tell you a simple technique by which you can solve the reactions and you can prepare the products. So first I am going to rub their names because they are taking a lot of space. So please write down their names, IUPAC as well as common names. The very simple technique is like this is acetyl chloride. So first give a charge. This is negative charge. This carbon will be positively charged, obviously, because chlorine is more electronegative than carbon. So these shared electrons are more toward chlorine side. So because chlorine is getting extra electron of carbon to itself, so that's why negative charge, and carbon is losing its control on its electron, so positive charge on it. Similarly here, this oxygen is carrying negative charge and this carbon is carrying positive charge. This also carrying positive charge. But because this acetic anhydride is symmetrical means left hand side of this oxygen COCH3 group, right hand side of this oxygen COCH3 group. So it's a symmetrical acetic anhydride. So from any carbon you can break bond. Like from here if I will break bond, same product will generate, and from here if I will break, same product will generate. From any side you can break the bond. Similarly here in benzoyl chloride, this chlorine is more electronegative than carbon, so negative, and this carbon positive. So first you simply need to put a charges over there. Now in phenol, This is phenol. As you know, oxygen is more electronegative than hydrogen. So electrons are shifted toward oxygen. As one electron of hydrogen is going toward oxygen, so it will carry a positive charge. Partial positive, because complete shiftage is not there, partial shiftage is there. And oxygen will carry partial negative charge. That's it. If acetyl chloride is going to react with phenol, so this negative will attack on positive, means on hydrogen, and this positive carbon will attack on oxygen. So when it will react with it, product generated will be this. This oxygen you have to join with this carbon and rest molecule as it is. Just simply positive negative attractions, and Cl will join with H. The side product will be HCl. So which functional group is generated, you can check. This is ester functional group. IUPAC name, if you will do, IUPAC name will be, this is the main chain. Numbering will start from here, 1, 2. As functional group carbon will get least number. And this phenyl will work as a side chain. Benzene ring as a side chain we call phenyl. Name of side chain we will write first, phenyl, then word root, eth. Single bond is there between carbon, so ane 1 O8. Because first position O8, O8 means ester. For ester in IUPAC name we use word O8, O-A-T-E. So this compound will generate. Now, if acetic anhydride reacts with phenol, so same technique. This is negative. Like here you have broken bond between carbon and Cl, and here any carbon oxygen bond you can break because symmetrical they are. So from any side, suppose I am breaking from this side. So this oxygen is going to join with positively charged hydrogen, and this positively charged carbon is going to join with negatively charged oxygen. So what will be the products? When this oxygen will join with this part, COCH3, this will generate again an ester, same ester, phenyl ethane 108, you can check. And what will be the side product? CH3COH will join on this oxygen, CH3COOH. Ethanoic acid, carboxylic acid is generated, ethanoic acid. Now if this is going to react with phenol, same technique. Negative chlorine will combine with positive hydrogen, HCl will be released out, and this positive carbon will combine with this negative oxygen. CO will join with this oxygen which is connected with benzene ring. Now this is also ester whose IUPAC name will be, this will work as a, this phenyl group will work as a side chain. So we will write it name phenyl first, and this will be the main chain, number will be 1. This will also work as a phenyl as a side chain. So again the name of phenyl, word root meth ane 108. This will be the, and the position of phenyl you can tell, 1 phenyl methane 108. Side product will be HCl. So you can check in all these three reactions, phenol is losing H positive. This H positive is going to attack on Cl. So because phenol is releasing H positive, means here phenol is working as a acid. Same here, this H positive is attacking on this oxygen. This H positive is attacking on this Cl. In all these three reactions, phenol is losing H positive, means it is working as a acid there. Now next points. This process, in this first reaction, you can check this part is known as acetyl. CH3CO group is known as acetyl. So acetyl is going to join on a phenolic part. So this process is known as acetylation. This process also we have done in alcohol. There at the place of phenol, alcoholic molecules were there. Acetylation. This one, this you can check. This is also acetylation process because COCH3 group is joined on a benzene ring. Again, it's a acetylation process. Acetylation we will call it. And this third process, because benzoyl chloride is going to react with phenol, it have a special name, we call it benzoylation. Benzoylation. So please note down the name of the processes, acetylation and benzoylation. Now next point, you can check what are the side products. HCl, ethanoic acid, HCl, they all are acids. If they keep on generating here, the reaction will try to move in a backward direction because stage of equilibrium will arise quickly. So it is important to finish these acids which are generated as a side product. That's why in these reactions, one more chemical we are using, base. The base is going to neutralize the side product acids. As they will finish, the reaction will continue in a forward direction and continuous generation of ester will be there, which is our main product which we want during this reaction. Which base? Pyridine. This base already we have used when alcohol was showing these reactions. Pyridine. Its formula, if I talk, this is the formula of pyridine. A cyclic 6-membered ring is there in which 5 members are carbon and 6th member is nitrogen. 1 member is nitrogen here. Total 5 hydrogens will be there. 1, 2, 3. This is a base. And one more point. This pyridine is there. Okay, why we are going to use it? To neutralize this acid. One more point. If at the place of pyridine, in this reaction benzoylation, we are using aqua NaOH as a base. In this reaction benzoylation, aqua NaOH means sodium hydroxide as a base. So this reaction will become a name reaction, Schotten Bowman reaction. Note it down. Schotten Bowman reaction. That's it. These are the information we have up to 12th level. Now, if for JEE, NEET and BSc, we are looking for mechanism, let me tell you what is the mechanism. Note down all these informations. Already these mechanisms are done. Where? Please check the videos in which I have done reaction of alcohol with acetyl chloride and acetic anhydride. Mechanism. Please check these videos. alcohol reacts with acetyl chloride or reacts with acetic anhydride or reacts with benzoyl chloride also, and benzoyl chloride. With same mechanism, phenol will react. There is no difference in the mechanism. So please check those videos. What you have to do, in those videos, I have used alcohol molecule, ROH. At the place of alcohol molecule, you just need to use phenol molecule. And rest mechanism will be same. There is no change. Every information is given there on those videos. Please check. For benzoyl chloride, special video I have not made with alcohol because acetyl chloride and benzoyl chloride, they have a same mechanism with alcohol. Actually, they are same, acetyl chloride, same functional group they have. Only the point is they are differ by alkyl part. What is acetyl chloride? CH3, COCl. And what is benzoyl chloride? At the place of CH3, benzene ring is same. Benzene ring is there. So their reactions will be similar to alcohol. Their mechanism will be same with alcohol as well as with phenol. So please check those videos. Thank you very much for watching the video. This is the end of chemical reactions of phenol in which it is showing acidic behavior. First acidic comparisons and then these three reactions. Up to 12th level, no mechanism. For JEE, NEET and BSc, mechanism is there. Special mechanism for phenol I have not made because alcohol mechanism we have done. Alcoholic mechanism is similar to phenol mechanism. Thank you very much for watching the video.